Welcome. Today we're going to take what we already know about ratios and rates and learn how we can apply that information when it comes to problems involving percents. So something to keep in mind, the word percent means out of 100, and this makes sense if we break this word up. We can think of this as per, so for each or for every, cent meaning 100, so this is for every 100 or out of 100. So 37% would mean 37 for each 100. Percents are really helpful to us when it comes to comparing values. Fractions can be difficult to use to compare if they have different denominators, so percents can just be a nicer option to use. Now for us, we are going to be talking about percents, parts, and wholes when it comes to these different word problems. And these are words that we're going to be using throughout this entire topic. So we can say a percent, meaning out of 100, is a ratio of the part to the whole. So we can see over here how this would look if we wanted to set this up as, for example, a proportion. For us today, we're going to be using equivalent ratios or a giant one to help us go from the part over the whole to the percent over 100 or vice versa. So let's look at our first example here so that we can see how we can connect these different words to these different numbers in the problem. So first we're told there are 80 animals in an animal shelter. Of those animals, 27.5% are dogs. How many dogs are at the shelter? Now, we need to make sure that we are identifying what information we have and what information we need to find. So of these three pieces of information, the part, the whole, the percent, we should always be given two of those numbers, and that means we'll have to solve for whatever one is missing. Now, usually, the easiest number to identify is going to be the percent. If we see something that has a percent symbol, usually that number is going to be our percent. So in this case, we can see we're told 27.5% are dogs. So that means we can go ahead and say that the part is 27.5%. You don't need to write the percent symbol with it because we already know this represents the percent. So out of every 100 dogs or 100 animals at the shelter, 27.5 of them are dogs. Next, we need to decide for this 80 animals here if that is going to be our part or our whole. So if we think about this, the whole is going to represent the total amount available usually. Part is going to represent a smaller subgroup of that amount. Well, we're told there are 80 animals at the shelter. We want to figure out how many dogs there are. Animals would encompass more types of creatures than dogs, so that means this 80 would represent the whole or the total amount of animals at that shelter. So we will say that the whole is going to be 80. Now we need to figure out the part. How many of those 80 animals are dogs? So since we don't know that information, I'm just going to put a question mark there for now as a reminder that that's what we're trying to figure out. When we're using equivalent ratios, we do not need to worry about actually using a variable in the problem. So we don't need to use x or d or p or anything like that. So now that I've identified the different pieces of information that were given in the problem, now we can go ahead and set up our ratios. So since we need to find the part, we wouldn't want to start with the part over the whole since we would only have one of the two numbers needed for that. Instead, we're going to want to start with the percent over 100. So we already know the percent over 100. And we're trying to change this into, eventually, the part over the whole. Well, our percent is 27.5 over 100. And we need to somehow eventually end up with 80 for the whole, and we don't know what will go on top of that. That's what we're trying to figure out. Well, I can go ahead and find essentially the unit rate. I can change this starting ratio so that we have a 1 in the denominator. Well, to do that, I could divide both numerator and denominator by 100. So if we do this, we'll end up with our unit rate where we have 1 in the denominator, and 27.5 divided by 100, that will be 0.275. From there, I need to now scale this up to give me 80, so I can multiply the numerator and denominator each by 80, and I will end up with my new rate, which is the part over the whole. Now, if we use a calculator, 0.275 times 80, that will end up giving us 22. So this tells us that there are 22 dogs at the shelter. So we started out with our percent over 100 because we knew what that information was. We used giant ones to scale down and then scale up the ratio so that we could find how many out of 80 animals were dogs, or the part over the whole. If we look at this next question, we're told in the 7th grade, 28 students are left-handed. In other words, 7% of the students are left-handed. How many students are there in the 7th grade? So first up, we need to identify what numbers belong to the part, the whole, and the percent. Well, I'm noticing this 7%, and it says 7% of students are left-handed, so that is going to be our percent. Up here it says in the 7th grade class, 28 students are left-handed. So we have to ask ourselves, is 28 the total amount of students in 7th grade, or is this how many students are left-handed? If we read carefully, we see that this is just how many students out of all 7th graders are left-handed. So this would represent the part. So our part will be 28 for the students that are left-handed. Now we want to find how many students are there in 7th grade. So that will be the total amount or the whole amount. So we do not know what that number is. Well, since we know the part, but we do not know the whole, then that means we're going to have to start with what we do know. So of our starting rates available, part over the whole, we can't use that since we don't know what the whole is. But we can start with the percent over 100. So we'll do percent over 100, and then we will eventually turn that into the part over the whole. So our starting rate will be the percent, which is 7. So we have 7 out of 100. And I need to somehow adjust this so that we have the part, which is 28, over the whole, which we do not currently know what that is. We're trying to figure that out. Well, I need to ask myself, what can I do to 7 to turn that into 28? In this case, I actually don't need to go through the process of finding a unit rate because I know that 7 times 4 will give me 28. So I'm just going to scale this up by 4. And 7 times 4 is 28, which is great. And in the denominator, 100 times 4 will give us 400. So this tells us that there are 400 students in 7th grade. If we look at this next example, here we're told that there are 2 students, Josh and Daniel, who are trying to save money to attend a sports camp. They've each saved $600. This is 120% of the amount needed to save. What is the original amount he needed to save to attend a sports camp? Well, if we're identifying the part, the whole, the percent, we're told this is 120% of the amount he needed to save, so our percent is 120. Now, you may think it's a little strange to have a percent that's larger than 100, but that's perfectly fine in these circumstances. So the percent is 120%. Now, we are told that the amount that they have saved is $600. We want to know how much they actually needed to save. So the amount that they've saved is what we will consider the part. So we can say they each saved $600. So we are trying to figure out how much they needed to save. That is going to end up being our whole amount. So this is what we do not know. Now again, since we do not know the whole, we cannot start with the part over whole. We need to start with what we do know, which is going to be the percent over 100. Then we can turn that into the part over the whole. Well, the percent is 120, so we can say 120 over 100. And we have to somehow turn this into 600 over something. We don't know what that amount is. Now, you could find the unit rate by scaling this down so there's 1 in the denominator and then scaling it up so that we have 60 in the numerator. However, if you use a calculator, you could see that 120 times 5 will end up giving us 600. Or, flip it around into a division problem, 600 divided by 120 will give us 5. So we can scale this up by a factor of 5 for the numerator and the denominator. And if we do this, 120 times 5 is 600. 100 times 5 is 500. So we can say he originally needed to save $500. So they actually, because they saved more than 100%, they saved more money than what they actually needed to afford the sports camp. So they could use that extra money for maybe snacks while they're there, or a cool shirt or something like that. For this next problem, we are looking at battery life. So we want to make sure that, our phones, our devices have enough charge to last throughout the time that we're using them. So here we're told Diego starts a 12-hour road trip with his battery charge at 75% on his phone. Given his normal usage, shown in this picture, will his phone last the whole trip? So first, we're going to try to figure out how many hours his phone should last if he's at 75% battery. Now we're assuming that there is a consistent relationship between the amount of time that he can use the phone and the percent battery. In the real world, sometimes when your phone gets or your device gets to a lower percent, like 7% battery, it'll die much quicker. We're assuming that is not going to be the case here, since that would complicate this too much. So if I'm looking over here at this information, we can see that if there is 100% battery charge, he can use the phone for 15 hours. So since the phone is only 75% charged, we want to know how many hours he has left of use. So since we do not know how many hours he has available out of the 15 full battery hours, that means we are going to try to figure out what that part is. This is what we do not know. So the part is unknown. We know the total amount of hours available to use is 15, so that will be our whole amount. And we know the percent battery charge is 75%. So for us, since we do not know what the part is, we're going to want to start with the percent over 100 and then turn this ratio so that it becomes the part over the whole. So we can start out. We know that the battery is at 75%, so this will be 75 out of 100. And we need to change this so that we have 15 in the denominator. And whatever's in the numerator, that will be our final answer. Now, I am going to go ahead and scale this down to find the unit rate. So I can do that by dividing 75 and 100 each by 100. So if we do this, dividing by 100, we will get the unit rate of 75 divided by 100 is 0.75. So 0.75 over 1. Now, to scale this up, To change 1 into 15, I can easily do that by multiplying by 15. So I can multiply the numerator and the denominator each by 15. And if we do that, 0.75 times 15, that will end up giving us 11.25. So this tells us how many hours of phone use his would have out of the 15 possible hours. Since his phone is not fully charged, it's only at 75%. So based on this information, since the phone only has 11.25 hours of use in it, and he's on a 12-hour-long road trip, his phone will die before he ends up finishing the road trip. So since the remaining battery life is 11.25 hours, so his phone won't last the whole 12-hour trip. Unfortunately, he'll need to either stop and charge his phone on the way, or maybe he can charge it in the car. Or he'll just have to go the last little bit of the drive without using the phone. Now, on the back, we have some information about some more real-world things, some more real-world facts. So something that's interesting to know is that a full set of adult teeth includes 160% as many teeth as a full set of baby teeth. This is partially because when you're born, your mouth is much smaller, so there just isn't room for as many teeth as what we have as an adult, because as you grow, the inside of your mouth also grows, so then there's room for more teeth. So looking at this information over here that we're told about different teeth and different types of teeth, we need to first identify what is 100% of the baby's teeth. So if you count all of the teeth in a baby's mouth, how many teeth should there be? Well, if we're looking over here, we can see there's 20 baby teeth in a full set or of baby teeth. So that means we are going to consider the total amount of baby teeth as our whole amount. That's the overall amount. So the total amount of baby teeth will be our whole amount. We want to know how many teeth are there in a full set of adult teeth. So since this is what we're starting with, this is sort of our original amount, we need to figure out the part, which we just don't know what that information is at the moment. We are, however, told the percent. We're told 160%. The amount of adult teeth is 160% of however many baby teeth people start with. So since we don't know the part, we can go ahead and calculate the, we can start with the percent over 100 and then turn that into the part over the whole. So our percent is 160 out of 100. And I need to adjust this so that the whole is some amount over 20. Well, I know that I can change 100 into 20 by dividing by 5, because it takes 5 sets of 20 in order to equal 100. So I'm going to go ahead and scale down our starting rate by a factor of 5. So if we divide 160 by 5, we'll end up getting 32. And if we divide 100 by 5, we'll end up getting 20. So we can say there are 32 teeth in a full adult set. All right, next up, we're looking at some really large numbers because here we're talking about the distances from Earth, the Sun, and the Moon. So we can see this modeled over here. The distance from the Earth to the Sun is approximately 93 million miles. The distance from the Earth to the Moon is about 0.27% of that distance from Earth to the Sun. So the Moon is much, 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 much closer. What is the approximate distance in miles from the Earth to the Moon? Well, we can see that our percent that we're given here is 0.27%. Now, it is a little strange to have our percent written as a decimal, but that's perfectly fine. So our percent is 0.27%. We're told that the total or overall distance from the Earth to the Sun is 93 million miles. The distance from Earth to the Moon is a smaller section of that. So the distance from the Earth to the Moon, this is going to be our part. This is what we don't know. Whereas the distance from the Earth to the Moon is going to be treated as the whole amount. So 93 million miles. So we don't know what the part is, so we're going to need to start with what we do know, which is the percent over 100. And we can eventually turn that into the part over the whole. Well, we're told our percent is 0.27 out of 100. And we need to somehow change this so that we have 93 million for the whole in the denominator, and whatever the numerator ends up being, that will be our final answer. Well, I can change 100 into 93 million. If I multiply or scale this up by 93, and I need to have 1, 2, 3, 4, 5, 6 zeros to have 93 million. I already have 2 zeros, so I need to multiply this with 4 extra zeros. So this ends up being multiplying it by 930,000. So I'm going to multiply that to both the denominator and the numerator. So I'm scaling up both of those values by 930,000. If we use a calculator, 0.27 times 930,000, we end up getting 251,100 for this missing numerator. So we can say the distance from the Earth to the Moon is about 251,100 miles. All right, 2 more word problems that we have here. A store sells a sweater for $40. The sales tax is $3.20. What is the percent of the sales tax? Now in this case, we are not told the percent. We are actually trying to find the percent. It says, what is the percent? So the percent is what we do not know. We can tell that the original price for the sweater, or the starting price for the sweater, is $40, and the sales tax is calculated based on that cost. So that means the price of the sweater is going to be our whole amount, and the sales tax is going to be $3.20. So that is going to represent the part. So in this case, we know the part and the whole, so we are actually going to start with the part over the whole, and then we'll calculate out the percent over 100 as a result. So here, we can begin with the part over the whole, 3.20 over the whole amount, which is 40. And we need to eventually end up turning this into something over 100. Now, I don't have a very convenient way of changing 40 into 100, so I'm going to go ahead and find a unit rate. So I'm going to divide the numerator and denominator each by 40 to scale this down. So we'll have 1 in the denominator, and 3.2 divided by 40, if you use a calculator to help you, you'll end up getting 0.08. So if the sweater cost $1, you would pay $0.08 or 8 cents for the sales tax. So we can now go ahead and scale this up so that we end up with 100 in the denominator for our final answer. So I can scale this up by multiplying 1 by 100, and I can do the same to the numerator. And 0.08 times 100, that will give us 8. And in the denominator, 1 times 100 will give us 100. So we can say the sales tax is 8%. So for every 100 cents, you pay an extra 8 cents in taxes, or in sales tax. All right, next up, Joel earns a commission of 5% on the audio equipment he sells, and the store keeps the rest. He sells a $750 amplifier. So we want to figure out two things. We want to figure out how much commission Joel earns from the sale, and we want to calculate how much money the store keeps as a result of that. So we're told that the commission is 5%, so that means however much he sells, he gets to keep 5% of that money. So our percent is going to be 5. We're told he sells a $750 amplifier, so some amount of that $750 is what he gets to keep in commission. He doesn't get to keep the whole $750, so that means that $750 will be the whole amount. So if he had a commission of 100%, he would get to keep all $750, but he only gets to keep 5% of that. So that means the part will represent how much money he gets to keep, and we're not sure exactly how much that works out to be. So since we don't know the part, we're going to start with our percent over 100 and eventually change that into the part over the whole. Okay, so we begin with 5% or 5 out of 100, and we somehow need to change this into something out of 750. Well, to turn 100 into 700, I would multiply by 7. So to turn 100 into 750, I could multiply by 7.5 or 7.5. So if I scale up the values in the numerator and denominator, each by 7.5, then 100 times 7.5 will give me 750. And if I use a calculator, 5 times 7.5 will give me 37.5. So we can say he earns $37.5 or $0.50 in commission. So that means that the store keeps the remaining amount of money. So if he gets to take home $37.50, the store will keep everything that's left over. So to find out how much money the store keeps, we can go ahead and subtract 750 minus $37.50. We can put in some extra zeros there. And if we go through and subtract, we'll find out that the store ends up keeping $712.50. There's a lot of businesses that operate using commission. So this is really common with car sales, sometimes certain electronics, like amplifiers or computer parts. So this is a way of encouraging the salespeople to really try to sell a lot of products so that the business can get money, but also so that the person selling it can earn extra money as well. Lastly, down here, these are some other types of problems that you can come across when you're working with percents. These are problems where there is no real world context. We're just given usually a very short question or a very short sentence, and we have to identify what information given and what information we're trying to find. So again, usually it's really easy to identify the percent because it's typically going to be whatever number has the percent symbol. So in this case, for our percent, we're told it is 0.08. Now, we need to figure out what 0.08% of 720 is. Now, since we're trying to figure out a percent of this amount over here, this 720 basically acts as our whole amount. So the whole is going to be 720. That means we're trying to find the part. We don't know what that amount is going to be. So we can start with the percent, since we know that. So our percent over 100, so 0.08 over 100, we need to somehow scale this up so that we can find some amount over 720. If we're looking at this, well, I can turn 100 into 720 by scaling this up by a factor of 7.2. So if I multiply both the numerator and the denominator by 7.2, then we can go ahead and calculate out what the part is. So 7.2 times 0.08 works out to be, 7.2 times 0.08. That works out to be 0.576. So let me make this a little bigger. So 0.576. In this next problem, 325 is what percent of 200? Well, we don't know what the percent is, so the percent is going to be what we're trying to find. Now, we're told 325 is the amount that we're working with, and it's out of, or of 200. So that means 200 is going to be the whole amount, and our part is going to be 325. So since we know the part and the whole, we can start with that information. So we can say 325 over 200, so we have the part over the whole, equals some amount over 100. This will be our percent. Well, I can easily change 200 into 100 by dividing by 2. So I can scale this down by a factor of 2. And if we do this, 325 divided by 2, that will end up giving us 162.5. So this would be 162.5%. Again, it's perfectly fine that in this case the part is larger than the whole, because we can have percents that are larger than 100%. And for this last example, 1.8 is 0.3% of what number? So we have our percent. We know that is 0.3. We're told 1.8 is what we end up getting when you find 0.3% of a number. So we don't know what that original number is, so that means we don't know what the whole is. So the whole is what we're trying to find, but we know that we end up with 1.3 or 1.8 once we take 0.3% of that original amount. So since we don't know what the whole is, we're going to have to find that at the end. So we can start out using our percent. So we have 0.3 out of 100. And we somehow have to change this into 1.8 out of some amount. We're not sure what that amount is. Well, I know that 3 and 18, I can multiply 3 times 18 to get 1.8. And if we use a calculator to turn that around just to check, 1.8 divided by 0.3, sure enough, that is, you end up with 6. So we can scale up 0.3 to turn it into 1.8 by multiplying by 6. So I can multiply by 6 to the numerator and to the denominator. So if we do that, 0.3 times 6 is 1.8. And 100 times 6 will give us 600. So we end up with 600 as our final answer. Now, one parting thing to keep in mind, when you see questions like this, oftentimes, if we see a number that has a percent symbol in it, that will be the percent. If we see a number that comes after the word of, usually the number that comes after the word of is going to be the whole amount. So here, 720 it's of 720. 720 is the whole. Something, something, something of 200. 200 is the whole. Something, something, something of what number? The whole is what we're trying to solve for. So if you see the word of, usually what comes after that is going to be the whole amount. If you have a number that comes before the word is, so over here we have the word is, the number that comes before that is usually going to be the part. So 325 is, and then the rest of the stuff, our part is 325. 1.8 is, so the part is 1.8. Over here, we don't have a number with the word is, So that's why we're trying to find the part. So if we see the word is, usually the number that comes before that word is going to be the part. And then if we see a percent symbol, that's how we can identify the percent. So we're going to practice more with the types of problems using other strategies of solving them other than using giant ones like what we were using here. So you'll continue to have more practice identifying the parts, the whole, the percents, whether it's in word problems or it's in these very summarized problems.